elementary elementary row operations. Right, don't forget, uh in the previous video we learned the definition of linear algebra. So right now we want to move forward and to be able to solve a system of linear equations. One of the methods, as a matter of fact, the best method of solving linear equations is using uh row operations. Yes, and this is where this is where it, it, it becomes tricky, because I know a lot of us want to say that, oh yeah, I know, I've done matrices, I've learned about determinants and everything, you know, but I can tell you that you are not used to this. I can tell you that for a fact. Yes. And why do we need to learn these elementary row operations? Because we want to be able to solve a system where we have infinitely many variables. You know, when you have a system where you have just uh, like this now, x plus y equals to 3x plus 5y equals 8. You know, a decent, any decent junior secondary school student should be able to solve this. You know, you can use elimination method, you can use substitution method, and even when you get to the higher grades, I mean higher classes, you can even use matrix method or even determinants if you are a further math student, you know. But what if you now have, you know, this one now only has two variables, it only has two variables. What if we have a system, what if we have a system with five variables? That is when all your favorite Cramer's rule, the inverse method, will fail. Have you ever tried to use inverse method to solve a 5 by 5 matrix before? It will be so cumbersome that you will know that no, this method is not efficient. So we're talking about efficiency here. So that is why we are adopting this new method, the elementary row operation, where we'll be using the reduced row echelon form. We're going to be talking about everything here. Now, this is easy. You can just go, well, I want to use the substitution method. You can use the substitution method and you can just say x equals 2 minus y, and you substitute into equation 2, you know, this is equation 1 and this is equation 2, so that equation 2 can just look like 3 into bracket 2 minus y plus 5y equals 8, and this will be 6 minus 3y plus 5y equals 8. So this will be 6 plus 2y equals 8, right? So that 2y can be equal to 8 minus 6. 2y equals 2 and y equals 1. So now that we found y to be 1, we can solve it, substitute into equation, or we can call this equation 3, into equation 3 here. So we have x will be equal to 2 minus 1 and x equals 1. So now, right now, we can see clearly that the solutions are, so the solutions are x equals 1 and y equals 1. Yes. So, but then, what if you now have a system with five variables, like five variables, like you have something like this, 3x1 plus 2x2 plus 3x3 plus 4x4 equals 10, and equation 2 is 6x1 plus 3x2 plus x5 equals 11, and you have equation 3. Equation 3 is now uh let's say 5x2 minus 3. Let's do 5 here. 5x3 plus 2x4 plus 3x5 equals 10. Now let's think about this system. Let's think. So for once, I want you to be able to appreciate why we are going to the need for learning elementary row operations. The need, I want you to see the need for going the reduced row echelon form, what I'm going to be introducing, as we progress in this course. Now, if you look at this now, there are five variables: x1, x2, x3, x4, x5, and there are only three equations. One would have expected that, oh, we have five uh we have five variables. So to be able to solve for five unknowns, we would have loved it if we had like five equations, like equation 1, equation 2, equation 3, equation 4, equation 5. Here, but sadly, we only have three equations. So I want to encourage you to use your normal substitution method that I used here. Please use it to try and solve this equation. Then you will see how horribly your methods, all those old methods, will fail. They will fail woefully. So this is why we need a more efficient method to be solving our systems of linear equations. Thank you.